biodiversity. Be a part of the solution, not a part of the pollution. Good morning, the Honorable Judges of Smart IoT 2022. First is one biodiversity containing abundant natural resources. Based on the Ministry of Environment and Forestry (KLAK) in 2021, the forest area in Indonesia reaches around 95.6 million hectares. So it is not surprising that this Indonesia is called the lungs of the world. Wildfire is burning that spread freely in either small or large area, the varying UV view. There are two causes for fire, including natural factor usually derived from influence of El Nino. Meanwhile, there is also human activity factors such as illegal logging activities. This forest fire phenomenon is still widespread in Indonesia. It is recorded that the Ministry of Environment and Forestry (KLHK), the number of forest fires in Indonesia increased from 2016 to 2021 with a cumulative amount reaching 3.43 million hectares. Considering that forest fires have a bad impact on the surrounding environment, there were various efforts to prevent and project forest fire, and Poaching have including streamlining legal tools, such as GIS tools, but the system has not provided optimal result because the system cannot determine the point of forest fire. It is important to periodically identify the cause of fire in protecting forests. Without knowing the cause for sure, forest fire protective action and Poaching will not be able to be implemented optimally. Therefore, an innovative solution is needed to overcome this problem. So, we are young innovators from Brawijaya University with Mr. Swan Septriadi as the advisor of our team, Preser, an innovative solution with the title of Smart Forest Monitoring. The monitoring and wireless sensor network is an anticipation of forest and putting the pressure in Indonesia.
Forest monitoring drones are one of the technological innovation. Smart forest monitoring using thermal MEMS sensor, drones, wireless sensor network, and multispectral camera. Drone system for monitoring forest fire is based on cloud computing and the Internet of Things, where this system is used for collecting, analyzing, and visualizing data. Besides, this system also provides intensive information that is useful to support the discussion-making process to forest supervisor. The innovation of IoT-based forest monitoring drones and cloud computing is expected to be an effective forest fire suppression technology tool and can be applied in the field to maintain forest sustainability in Indonesia. Here are the material and the tool that we use to produce smart forest monitoring. There are the HD22 sensor, drone multispectral camera, MEMS thermal sensor, Arduino Uno, user monitoring, and sensor MK135. Here is the flowchart system of our tool. The node sensor will take data from the sensor in the form of temperature, humidity, and gas content, which will then be sent by the node sensor to the coordinator node. The coordinator node will send that data again to the gateway node to determine what action will be taken next. If the data contains potential fire hazard and forges, the system will automatically sound and display potential location.
Here are two parts of the design carried out. They are first system hardware design, first monitoring drone design. On the monitoring drone, there is a multispectral camera in the drone. The innovation that will be implemented we added a D60 MEMS thermal sensor to see in detail about the condition of the location that has the potential for forest fires due to the vultures. This sensor is placed under the drone sections. The location is also adjusted so that the data retrievable on the D60 MEMS thermal sensor is maximum and it's not covered by other drone components. Second, wireless sensor network design. The wireless sensor network, or WNS, consists of the design of a communication radio and a microcontroller in its design. Starting from a communication radio device using the XB Pro S2B type, the XB Pro S2B requires a power supply of 3.3 volts and has a transmission range of 3.2 kilometers. For microcontroller devices, we use Arduino Uno and will integrate into XB Pro S2B. And the second is system software design, program nodes. The design of the Arduino Uno microcontroller program node will use the Arduino IDE software. And in programming, we'll use the parsing method to distinguish and decipher the data on the input packet. The input data that is parsed is node address, humidity, temperature, and gas content data. XB Pro S2B configuration. XB Pro S2B can be configured as a receiver and transmitter using the multi-hop network of the IEEE 802.15.14 ZigBee protocol. In order for this tool to communicate using a multi-hop network, it must first be set up using SCTU software and XB adapter devices. Database designing on the MySQL platform. The database will be built using the MySQL platform, which can be addressed by the client at any time and live server. The column available on this technology include time, research index, and data description. Then the data stored in the name of Smart Forest Monitoring underscore data on the MySQL server platform includes node address, humidity, temperature, and gas content. And the last is application design for user monitoring. Designing application for user monitoring using Android Studio software. In this application, data stored on the MySQL server platform is displayed. Then the data displayed is in the form of human detectors, sensor points, and monitoring. As for accessing the application, an internet network connection is needed.
Next, data and observation. Here are some data of a constituent component used in this innovation with the aim of explain the function of its part, so that the result of the data and prototype can be designed as follows. Next, data analysis. Delay analysis measurement is carried out of determine of the quality of sending and receiving data provided by each sensor to a wireless network sensor. For example, in a Juana Forest Park area with the resulting delay parameters as follows. And next, packet loss ratio and analysis. Packet loss ratio and analysis is an estimate of the data loss against a complete data packet defined the form of a percent.
Test analysis and product evaluation. Benefits in technology used to monitor the situation from above the forest area. The use of IoT-based technology in the farm drones in monitoring protected forests periodically allows the use of time and cost to monitor the state of protected forests remotely to be more effective and efficient. In this drone, it's also equipped with a multispectral camera and MEMS thermal. Multispectral camera has the advantage of being able to provide the invisible information in the form of a color spectrum. This makes this camera able to detect the temperature of an object so that it can minimize the possibility of fire early. On the other hand, thermal also support the process of detecting the movement of every human being in protected forest by analyzing their temperature. So that with this technology, forest ranger will be able to monitor every movement that occur in the forest, but the state of forest temperature that cause fires and the movement of every human being in the forest or prevent poaching in protected forests. So we can know the conclusion is forests are included from biodiversity that contains abundant natural resources. However, this forest fire phenomenon still occurs a lot in Indonesia. Recorded by Ministry of Environment and Forestry or KLHK, the number of forest fires in Indonesia increased from 2016 to 2021. With a cumulative amount reaching 3.43 million hectares. Therefore, smart forest monitoring, drone monitoring, and wireless sensor network as an anticipation of forest fires and poaching are innovative to overcome this problem in order to preserve forests in Indonesia. That is all from us. Thank you for your attention.